Today, we are diving into the most brilliant celestial beacon that has guided civilizations, inspired myths, and puzzled astronomers for millennia. Sirius, the brightest star in Earth's night sky. On a clear dark night, far from city lights, you can spot it almost instantly, glowing with a steady, intense radiance that makes every other star look dim by comparison. It is so luminous that it can even be seen faintly during daylight hours, under the right conditions, a feat no other fixed star can match. For anyone who has ever looked up and wondered about the most eye-catching star in the cosmos, this is the story of Sirius, a star that is not just a single point of light, but a dynamic binary system, a historical cornerstone, and a living laboratory for astrophysics. Let us start with the basics that make Sirius unbeatable in the night sky. Its official astronomical name is Alpha Canis Majoris, marking it as the brightest star in the constellation Canis Major, the Great Dog, hence its beloved nickname, the Dog Star. Its visual, apparent magnitude is 1.46, making it nearly twice as bright as Canopus II, brightest star, and roughly 25 times brighter than Polaris, the North Star. This extraordinary brightness comes from two key factors: its intrinsic luminosity and its incredible proximity to our solar system. Sirius lies just 8.6 light-years from Earth, making it the fifth closest star system to our Sun, a close neighbor in the vast stretching expanse of the Milky Way galaxy. Unlike distant supergiant stars that shine brightly but are thousands of light-years away, Sirius combines nearby distance with high luminosity, creating an unrivaled visual impact for observers on Earth. Long before telescopes or astrophysics, Sirius was a sacred star that shaped the rise of human civilization. In ancient Egypt, it was known as Sopdet, the star of the Nile, and its annual heliacal rising, when it appeared just before the sun at dawn, signaled the coming of the Nile River floods. This flood brought fertile silt to the arid Egyptian plains, allowing crops to grow and sustaining one of history's greatest empires. Around 3000 BCE, Egyptian astronomers used the consistent cycle of Sirius' rising to create the first 365-day solar calendar, dividing the year into 3 seasons tied to the Nile's rhythm: flooding, planting, and harvest. This calendar later evolved into the Julian calendar and eventually the modern Gregorian calendar we use today, meaning Sirius indirectly shaped the way we measure time across the entire world. To the ancient Egyptians, this star was not just a light in the sky. It was a divine messenger that governed survival, agriculture, and the very order of their society. The ancient Greeks and Romans also held Sirius in profound, if complicated, regard. The name Sirius comes from the Greek word Sirios, meaning scorching or glowing, a reference to the sweltering summer days that coincided with its morning rising. For Greeks and Romans, this period was the dog days of summer, a time when the dog star's heat was thought to add to the sun's intensity, bringing drought, exhaustion, and even illness. In Greek mythology, Sirius represented the loyal hunting dog of the great hunter Orion, placed in the sky forever by the gods, to follow its master across the heavens. This myth linked the star to loyalty and companionship, a poetic contrast to its reputation as a bringer of scorching heat. Across every ancient culture that observed it, Sirius was more than a star. It was a living part of daily life, religion, and storytelling. Now, let us uncover the cosmic secret that eluded stargazers for thousands of years. Sirius is not one star, but two, a binary system, locked in an elegant 50-year orbital dance. The primary star we see with the naked eye is Sirius A, a hot blue-white, A-type main sequence star, in the prime of its life. It is about twice the mass of the Sun, 1.7 times wider, and burns with a surface temperature of nearly 9,940 Kelvin, almost twice as hot as our Sunday. It generates energy through hydrogen fusion in its core, just like the Sun, but at a far more intense rate, producing 25 times more light than our home star. For a long time, astronomers assumed this was the only component of the system, but subtle wobbles in Sirius A's motion told a different story. In 1844, German astronomer Friedrich Bessel noticed that Sirius A did not move in a perfectly straight path across the sky. It wobbled slightly, as if being tugged by an invisible gravitational partner. He deduced that a faint, unseen companion must exist, but it took nearly 20 years for proof to arrive. In 1862, American telescope maker Alvin Graham Clark became the first person to observe the dim companion, Sirius B, while testing a new refracting telescope. This discovery revolutionized astronomy. Sirius B was the first white dwarf star ever identified, a stellar remnant that challenged everything scientists thought they knew about stellar death and density. Sirius B is a cosmic oddity and a testament to the dramatic life cycle of stars. Once the more massive of the two original stars in the system, about 5 times the Sun's mass, it burned through its nuclear fuel, far faster than Sirius A. After expanding into a red giant and shedding its outer layers, its core collapsed into an ultra-dense white dwarf, roughly the size of Earth, but with nearly the same mass as the Sunday. A single teaspoon of Sirius B's material would weigh several tons on Earth, making it one of the densest objects in our galactic neighborhood. It is about 10,000 times fainter than Sirius A in visible light, so it is completely drowned out by the primary star's glare when viewed with small telescopes. NASA's Hubble Space Telescope captured the first clear, detailed images of the pair, revealing the tiny faint dot of Sirius B, nestled beside the blazing glow of Sirius A. The two stars orbit their common center of mass at an average distance of 20 astronomical units, about the same as the distance between the Sun and Uranus, with an orbital period of 50.1 years, creating a slow, graceful, cosmic dance. NASA has long used Sirius as a critical calibration tool for space telescopes, thanks to its extreme brightness and stable light output. The Chandra X-ray Observatory has studied the system's high-energy emissions, revealing unexpected X-ray radiation from Sirius B that helps astronomers refine models of white dwarf physics. The James Webb Space Telescope, the most powerful space observatory ever built, has analyzed the infrared signature of the Sirius system, detecting faint dust disks that may be leftover material from the evolution of Sirius B. These observations confirm our understanding of stellar evolution. Massive stars live fast, die young, and leave behind dense white dwarf remnants, while lighter stars, like Sirius A, enjoy longer, more stable lifespans. Looking ahead, Sirius has a fascinating future in our skies. It is currently moving slowly toward the solar system, and over the next 60,000 years, it will brighten slightly to a peak apparent magnitude of 1.68, becoming even more dominant in the night sky. In about 66,270 years, Sirius will even take a turn as the southern pole star, a role it will hold for centuries before continuing its journey across the galaxy. Eventually, Sirius A will exhaust its core hydrogen, expand into a red giant, and follow the same path as Sirius B, ending its life as a white dwarf. The two white dwarfs will then orbit each other for eternity, slowly cooling and fading into the cosmic dark, a quiet end for a star system that once blazed brighter than any other in our sky. What makes Sirius truly special is how it bridges the gap between ancient human wonder and modern scientific discovery. It is a star that guided farmers and kings, inspired myths and calendars, and later became a cornerstone of stellar astrophysics. It reminds us that the brightest objects in the sky often hold the deepest secrets, and that the stars we take for granted are dynamic, evolving worlds with their own dramatic histories. Every time you step outside on a clear night and spot Sirius glowing brightly, you are not just seeing a star, you are seeing a link to ancient civilizations, a laboratory for cutting-edge physics, and a shining example of the universe's boundless capacity to surprise and inspire. Sirius is more than the brightest star in the night sky. It is a teacher, a guide, and a storyteller. It teaches us about stellar life cycles, gravitational dynamics, and the scale of our galaxy. It guided ancient civilizations through time and seasons. It tells a story of cosmic change of stars being born, evolving, dying, and leaving their marks on the universe. In a sky filled with countless stars, Sirius stands alone as the brightest, a constant reminder of the beauty, order, and mystery that await us beyond our world. Whether you are an experienced astronomer or someone who simply enjoys looking up at the stars, Sirius invites you to pause, wonder, and explore the infinite cosmos that surrounds us all. Please like, comment, share, and subscribe to the channel.